Let's do example 4, verifying a right triangle. Show that the points 2, 1, 4, 0, and 5, 7 are vertices of a right triangle. So first what we need to do is we need to use the distance formula in order to find out what the distance is between each of these points. So I'm going to start with this one first. So we do distance equals the square root of 2 minus 4 squared plus 1 minus 0 squared. So that is going to be the square root of 4 plus 1, which is the square root of 5. So let's do the next one. So I'm going to check this one and this one. So this distance equals the square root of 4 minus 5 squared plus 0 minus 7 squared. So the distance equals the square root of 1 plus 49. So this distance equals square root of 50. Then let's do the last one. And so that will be this first one and this last one. So distance equals the square root of 2 minus 5 squared plus 1 minus 7 squared. So this distance equals the square root of 9 plus 36 equals square root of 45. So now we know that the distances between all of the points, we can assume that number one, this here is our hypotenuse, and the other two are the legs. So remember that when you have a squared plus b squared equals c squared, then you know it's a right triangle. So we have to do that. Square root of 5 squared plus the square root of 45 squared. Does that equal the square root of 50 squared? And yes, this is definitely square root of 50 does equal square root of 50. And so, I'm sorry, not square root of 50, but 5 plus 45 equals 50, not square root. So 50 equals 50, and so therefore this is a right triangle.